All right, number 18. This is the second day of doing this video, by the way. Number 18 is where we left off on. I need to make this top a fraction, just one fraction instead of two fractions, and then a fraction divided by a fraction. I'm going to keep it, change it, flip it. So I'm going to multiply the top by x over x, this one by 3 over 3, and that's going to be 5x minus 9. So it's going to be 5x minus 9, all of this divided by 3x, all of that divided by 25 over 1. Alright, so I guess I can kind of think of this 25 over 1, I'm going to do that in yellow, and then the top is going to be, I'll make that green, so it's a lot easier to distinguish what I'm about to do here. So I'm going to keep it, I'm going to do 5x minus 9 over 3. I'm going to change it, keep it, change it, flip it, and flip it 1 over 25. And that will give us 5x minus 9 over 75. And I think that's as far as we can get because the top can't be factored anymore. Number 19 is kind of the same thing. We have to get this bottom into one fraction. So I'm going to multiply by 5 over 5, and that's going to give me 5x minus x all over 25. That can be simplified to just 4x over 25. And then the top stays the same, so the top was x squared over 1. The bottom is this. So I'm going to change it, keep it, change it, flip it. I'm going to flip this to 25 over 4x. Notice that there's an x right here, and there's an x right here. So I'm going to cancel out that, and the x's cancel out. Let me do that. And I'm left with 25x over 4. And that is as far as I can simplify it. And let me just check my work. So 18 looked like that. 19 was that. 19 was 25x over 4. Let's check our work. 19, 25x over 4. It looks like we're on the right track. All right. On to number 20. Solve each equation. Remember to check for extraneous solutions. Extraneous solutions are setting the bottom equal to 0. So this thing means set the bottom or the denominator equal to 0. Alright, so in order to do the subtraction, well, these are like terms, so I can just subtract them straight on. So 4 minus x minus 5, again, this negative sign is distributed into both of these. I don't know what happened there. Maybe I'll solve by scrolling up and down. It does. That's all over 3x squared is now equal to 1 over x. I'm going to cross multiply. Here's a shortcut for cross multiplying. I'm just going to multiply this x up here, multiply both sides by x. I'm assuming that both sides, or x is not 0, because x can't be 0 on the bottom, and that x will now come up here and cancel out here, so that's still equal to 1, therefore this 3x squared is going to come, actually I can cross out an x right now. Okay, this is the shortcut that I wanted to show. That x and that x cancel out, but I guess if I just keep this as cross multiplication, you'll see that as well. Sorry for being so confusing. So I have x times 4 minus 5 is negative 1. Negative 1 minus x is equal to 3x squared. That comes from cross multiplying, and then I'm going to distribute. That's going to be negative x minus x squared is equal to 3x squared. And then from there, I'm going to add x squared, and then add x. I'm going to add everything on this side to this side, so it's going to be 4x squared plus x is now equal to 0. I'm going to factor out an x. So I'm running out of room here. I'm going to come back up here. So I'm going to factor out an x. So 0 is equal to x times the quantity of 4x cubed plus 1. And that means I have two problems. X is equal to 0. All right. I realize that I made a mistake up here. It should have been 4x, not to the power of 2. Because obviously when you take away 1 from 2, you get 1. So that means that I have this other equation, which now becomes 4x plus 1 is equal to 0, and x is equal to negative 1/4. Now I have to check for extraneous solutions, so set the bottom equal to 0. If the bottom is equal to 0, that can't be 0, that can't be 0, that can't be 0, so the answer cannot be 0. So cross that one out. The answer is only negative 1/4. Alright, and on to number 21. So again, the bottom can't be 0, so I'm going to say that the extraneous solution here is 0. So if I get 0, don't do it, because obviously that can't be 0, that can't be 0, that can't be 0. So this one I don't have like denominators. I need to multiply the top here by top and bottom by 2, and then I'm going to get 2 over 4n. all this over 4n now. And then 2 minus 3n, and then that negative also distributes into this negative 15 to make it a positive 15, is equal to 1 over n. All right, time to cross multiply. When I cross multiply, by the way, 2 plus 15 is 17, so it's going to be 17n minus 3n squared. This negative 3n and n obviously make n negative 3n squared. All of that is going to equal 4n. And if I get everything on the same side, I'm going to move everything to the right side because I like positive quadratic terms, positive powers of 2. So I'm going to move everything to the right hand side. When I do that, I'm going to get 3n squared minus 14n is equal to 0. Obviously I'm going to factor out a 0 here, or factor out n here. So n times the quantity of 3n minus 14. From there I get n is equal to 0, or 3n minus 14 is equal to 0. If I do 3n minus 14 is equal to 0, that comes down here, and n will equal to 14 thirds. And it can't be 0 because 0 is an extraneous solution. Cross out the 0. Our answer is only this 14 thirds. Let's go ahead and check that work again. That was number 21. I guess I should have this open in another tab so I don't have to keep scrolling up and down. 13 thirds. Uh-oh, what did we do wrong? 13 thirds. I just can't do math. 4 minus 17 is 13, so that's my bad. This should be a 13. That should be a 13. 13. That should be a 13. Grab that. I just can't do addition and subtraction. Okay, and everything got messed up, so let's scroll up and down again. So coming back here to fix my work, 13, 13, 13, and 13. There, now I have the right answer. All right, number 22. Identify holes, vertical asymptotes, x-intercepts, and horizontal asymptotes of each. All right, so holes are where the top and the bottom, so top and the bottom are 0. Vertical asymptotes are where the bottom is equal to 0, so like 1 over the bottom. X-intercepts are where the top is equal to 0, so top over 1. Horizontal asymptotes are the limit to infinity. So limit, I should say, limit as x approaches infinity. All right, so we have to do 4 things for each of these problems, which is kind of a lot. So I'm going to go ahead and factor this guy. If I factor out an x, I'm left with an x minus 1. On the bottom, I'm going to factor out a negative 2, and I'm going to be left with an x squared minus 2x minus 3. I need to now do a ninja star on this guy, so my new problem, my new f of x is, I'll do it over here, x times the quantity of x minus 1 on top. And on the bottom, I have still the negative 2, and then after doing the advanced ninja, or I guess you can do a normal ninja star for this one, I'm going to have x minus 3 and x plus 1. X plus 1. And shame that that wasn't a plus 1 because that would cancel out. So it looks like on this one we have, so let's talk about the holes here. Holes. Holes where the top and bottom are 0, so nothing matches on the top and bottom, so none. There are no holes. If I'm talking about vertical asymptotes, vertical asymptotes are where the bottom is equal to 0, so set both of those to 0. X minus 3 equals 0 means at x equals 3 and negative 1. So that's 0, that's 0. And finally, x-intercepts, that happens where the top is 0. So this thing, 0, so that happens at x equals 0 and x equals 1. And finally, the horizontal asymptote, so I'll say horizontal asymptote. That's where I take the limit as I approach infinity, which I come back to this thing. I don't actually have to factor anything. Limit as x approaches infinity, cross out all of the tiny stuff. So cross out all of this, I'm just left with x squared over negative 2x squared. And then finally from there, I'm going to cancel out the x squared terms. And that's going to be left with a 1 over negative 2, so it's negative 1/2. So I'm going to undo that so that people can see the answer key. But the answer here should be negative 1/2. Can I not? I guess I have to grab things manually. I'll go like this. Negative 1/2. Negative 1/2. Let's check our work. So 3, negative 1, 0, 1. How well did we do here? 3, negative 1. There are no holes. horizontal asymptote is at -1/2, 0, 1. Yeah, we got it all right, nice. They just did it a little bit out of order, which is kind of annoying. Again, we're doing the same thing for 23. We might as well do the horizontal asymptote right now. So we'll say horizontal asymptote. That's where we again cross out all the small insignificant things, and then from there we cancel out the x to the power of 3, so the horizontal asymptote is going to be -2. So it's going to be -2. Okay, from there I'm going to do all the rest of the work, so I'm going to factor this thing. So when I factor this, it's going to be, I have a -2x to the power of 2 on the top, and when I factor that out, I'm left with an x minus 2. Alright, and then from there, the bottom, what is that going to factor as? I can factor out an x, so if I do that, I'm going to write it underneath here, because that's going to be an intermediate step, x to the power, or x times the quantity of x squared minus 6x plus 8, and then from there I'm going to ninja star that and put it right here. So when I ninja star this, it's going to be 2 and 4, minus 2 minus 4, so x minus 2, x minus 4. Hey, notice that these things cancel out. That means that that is a whole. Whole is whenever you cancel the top and bottom out. Alright, so let's talk about wholes. You have a whole at x is equal to 2 because that's where the top and bottom. For vertical asymptote, that's where the bottom is equal to 0. So while 2 is on the bottom, but that's on the top and the bottom, so what's left is just x equals 4. And then from there, we're looking for the x-intercepts. X-intercepts happen only at the top, and this has already been used up, the x minus 2, so I'm just left with this x squared. So that is 0 when x is 0, so x equals 0, and I'm done. Those are the 4 things I am looking for. Alright, now we are on to number 24. Alright, so number 24, simplify. Your answer should contain only positive exponents. Okay, so whenever I multiply, add. It's that simple. And make sure you're only adding things with the same base, so x. Alright, so yeah, again, you're just adding. So let's look at all the x's. I have x to the power of 1 plus this -1, and let's do all the y's. Y to the power of -2 plus -1. Alright, and that simplifies to x to the power of 0 times y to the power of -3. Anything to the power of 0 is 1. So that goes away, and we are just left with, only positive exponents. So this y to the power of 3, that needs to get turned into 1 over y to the power of positive 3. And since there's no x, that is our answer. Let's take a look at number 25. 25 has a coefficient which we are not going to touch. We're going to leave that as 4. Let's do all the m's. Count all the m's. I have 3 plus 2. Let's count all the n's. N's have 3 plus 4, and that simplifies to 4m to the 5th, n to the 7th. Done. It's that easy. Just make sure that when they're being multiplied, you add them. Add the exponents. The coefficients you do multiply. Alright, everything to the power of 0. This 0 is going to be multiplied to everything. So it's going to be multiplied to the 2, multiplied by the 4, and this 4 is going to be, even though I'm going to distribute it here, this 4 is really to the power of 0. So after distributing, I now have 4 to the power of 0, m to the power of 4 times 0, n to the power of 2 times 0. Well, 4 to the power of 0 is 1. So 1, m to the power of 0, that's m to the power of 0, n to the power of 0. Anything to the power of 0 is 1. So the answer here is just 1. And we could have taken a shortcut. It doesn't matter what you have on the inside, because this inside, think of it as this blue circle. Blue circle to the power of 0. Anything, including a blue circle to the power of 0, is just 1. This one is a little bit more tricky, so this 2 gets applied here, here, and here, so it's going to be 3 to the power of 2. X to the power of 4 times 2, y to the power of 4 times 2. Well, 3 to the power of 2, that's 9. X to the power of 8, y to the power of 8, done. Alright, solve each equation. So I need to have this same base here. I know that there's no way to get 81 to some power to get to 243, but I do see that 81 is 3 to the power of 4, and if you don't believe me, 3 to the power of 4 is indeed 81. So this is 3 to the power of 4, all of that to the power of 2x. That is equal to, and then if I do 3 to the power of 5, that's not how you type it, Mr. Sindel. 3 to the power of 5 is 243, so this is 1 over 3 to the power of 5. I want to have the same base. I want them both on the top, so I'm going to do a little bit of magic here. 3 to the power of, I'm going to multiply these, because when you do a power to the power, that means multiply. It's going to be 8x. and this is going to be equal to 3 to the power of negative 5. Well, once the bases are the same, they're both on the top, you basically just cancel them out. What you're really doing on here is you're taking log base 3 of both sides, if you want to be technical about it. But yeah, the only way for these to be the same is if their exponents are the same. So 8x is equal to negative 5. From there, I'm going to divide both sides by 8, and x is equal to negative 5/8. Alright, from there, it's kind of the same thing. The only way to get the same bases here is base of 4, so 4 to what power 16? 4 to the power of 2. And then that's to the power of 3b. 4 to what power is 64? Well, 4 to the power of 3 is 64. And then from there, I'm going to distribute here, multiply the 2 and the 3b. That's going to be 4 to the power of 6. I don't know, my 6's and b's are going to look the same. 6b. B. Good enough. Is equal to 4 to the power of 3. Therefore, 6b is equal to 3. And from there, divide both sides by 6. And b is equal to 1/2. I guess I should be boxing my answers here. And number 30. This one I'm going to have to do the same thing that I was doing above. So 2 to what power is 64? Well, 2 to the power of 2x is on the left-hand side. 64 is 2 to the power of, let's see, 3 is 8, 4 is 16, 5 is 32, which means 6. And I can just check my work, 2 to the power of 6. It is 64. That means 2x is equal to 6. That means x is equal to 1/3. This one is already set up for us, so they're both a base of 5, so 3n needs to be equal to 3n plus 2. Subtract both sides by 3n, 0 is equal to 2. That means this is impossible. So you can say impossible or no solution. I didn't know I gave that type of problem, but let's look at 31 to see if that was the answer. 31, yeah, is no solution, no answer. That's good enough for me. Coming down here to number 32, simplify. Your answer should contain only positive exponents. Kind of cool. Okay, so whenever I divide these exponents, I'm really subtracting them. So first of all, 2 on the top, 2 on the bottom, those go away. Let's look at the v's. V, this was v to the power of 1, so v to the power of 1, and then I'm going to subtract whatever I have in the bottom. 0. That's pretty straightforward. Let's look at the u's. u's to the power of 4, I'm going to subtract whatever's on the bottom, subtract a negative 4. Well, that simplifies to v to the power of 1, which is just v, and then u to the power of negatives kiss, they become positive. U to the power of 8 is a better 8. Final answer, done. Next problem. 3 on the top, 3 on the bottom. Ooh, very similar to the last one. Sometimes I'll do a 3 and a 9, and then it'll simplify to 1/3. What do I have? U to the power of negative 1, subtract 4, v to the power of 2 minus 2. This simplifies to u to the power of negative 5, but that's a problem because I need only positive exponents. This is v to the power of 0. Anything to the power of 0 is 1. That cancels out. Our answer here is 1 over u to the power of 5. On to evaluating logarithms. This is asking what power, right? What power does 2 need to be raised to get to 16? 2 to what power 16? Well, 2 to the power of 5 is equal to 16, so the answer here is 5. 5 is the answer. And if you check that, 2 to the power of 5 is the only thing you need to check. Oh, I messed it up. It's 2 to the power of 4. Let's come back here. 2 to the power of 4 is equal to 16, so the answer is 4. Same thing, 3 to what power is 243? Hopefully I don't mess this up. 3 to the power of 5 is 243, so the answer is 5. These are the same things, so 9 to what power gives you 3? Well, if I take the square root of 9, that'll be 3. The square root of 9 is equal to 3. 9 to the 1/2 is equal to 3. Again, we're looking for the power. What power gives me that answer? The answer is 1/2. Same thing here. It is very similar. The square root of 49 would be 7, but how do I get it negative 1/7? So again, the question here is 49 to what power here, what x power gives me 1/7? Or I can ask this another way. I'm going to do it slightly different than problem number 36. I'm going to say 7 to the power of 2 is 49. This is 49. That needs to be taken to the power of x. That needs to be equal to 7 to the negative 1. The negative 1 is 1 over 7. From there, that's going to be 7 to the 2x is equal to 7 to the negative 1. Set 2x equal to negative 1, and x is equal to negative 1/2. That's a bad 2. There we go.